Good morning, Fabulous Fives. Good to have you with me again today. Let's carry on looking at some shapes and something else to do with them today. Standard start of the lesson reminders. You can email me. I'm Mr. T. The email is grade5@worksheetcloud.com. Shout if you need any help with anything. If there's something your teacher's doing that you feel you think to yourself, maybe Mr. T could explain this a little easier. You never know, maybe your teacher's much better at explaining things than me. I know that definitely time is something I struggle with a little bit, but I hope you got it the other day. Anyway, after the lesson, click on the link above, do the worksheet, and make sure that you've got what it is that we're doing today. Sort of next slide is the mental arithmetic practice for today. 10 questions. I think I did subtraction. You've got 40 seconds. Accuracy over speed, but speed is important. You just write the answer. Afterwards, we'll go through and you can mark it yourself. Your 40 seconds start now. Halfway. And stop. We'll go through them. If you miss any, you can always go again. Remember, if you get it right, just give it a tick. If you get it wrong, just put the right answer next to it. 8 minus 4 is 4. 14 minus 5 is 9. 14 minus 9 is 5. 15 minus 6 is 9. 14 minus 10 is 4. 15 minus 15 is 0. 13 minus 8 is 5. 15 minus 8 is 7. 5 minus 5 is 0. 13 minus 9 is 4. If you missed any of those, rewind the video, watch it again, and mark them. We've also come accustomed to doing one of these at the start of each lesson, something that gets your brain thinking. This one is slightly different. It says solve if you're a genius, but really it's just solve if you know how to do maths. All right, so just a couple of quick things to take note of. First up, for each of these, you were working out what one star biscuit is. I assume these are all biscuits. That's a snowman biscuit, that's a bauble biscuit, and that's a star biscuit. Anyway, over here you've got 3 star biscuits. Over here there are 2 star biscuits. So whatever one of these is worth, this will be twice as much. That's something sometimes people get caught out with. Secondly, you cannot start by solving the first row, because if you just look at the first row, there's more than one possible answer that would be correct. So I could, for example, say that this was a star biscuit was equal to 1, and then each of my snowmen would be 24. I could say that my star biscuit was worth 3, and each of my snowmen was worth 21. And both of those would give me 45. And so there are quite a few different answers that would work. So in fact, what you need to do is start with the second line, then work back to the first line, and then work on from there. Right, so give it a go. I'm going to switch across to the whiteboard where I already have this, and then I'll give you a little bit of time to start, and then we'll have a look at the answer. Or more important than the answer is how to solve it. So remember, you want to start with the second line. I'll give you like another 20 seconds, which is ridiculously too little time, but I hate sitting here in silence. And you can always just pause the video while you solve it and then switch it on when you're ready to continue. That's all the time I'm giving you. I can't sit here any longer. I think if I was at school, in fact, no, I think when I was at school, I was one of those children who was up and down all over the show. And I think my teachers probably were a little bit frustrated, shall we say, by Mr. Travis running around and not being able to sit still. Anyway, At least I concentrated in maths. Okay, so looking at the second one, which is the one I suggested you start with, because we've got all the same, so we've got 3 star biscuits, we can work out what they are. They come to a total of 15. So what I'm looking for is 3 things that are the same that will add to 15. Another way of saying it is to say 15 divided by 3. So share 15 out equally into the 3. And that gives me 5. So each of these biscuits is 5, and there is no other possible correct answer for that, unlike the first line. So now that I know what a star biscuit is, I can actually put that in over here, and I can go right ahead and put in that this is 2 star biscuits, which is worth 10, because if 1 star biscuit is worth 5, then 2 is twice as much. Okay, but back to working out what the snowmen are worth in the first line. So I have a total of 45 that I need to get to. I already have 5, which means I need to have another 40 if I want to get to 45. Because the snowmen are the same, I need to share 40 equally between the 2 of them, which means that my snowman is worth 20. So half of 40 is 20, and I can put that in now, which means that this is 20. So the only thing we still need to work out is the bauble, that little red thing. We've got a subtraction problem here. What color should we use for this? Let's go with green. Okay, so 20 minus something gives me 12. I think we've done plenty of these in mental maths. So 20 minus what gives me 12? You can count backwards if you can't see this one immediately. So 19, 18, 17, 16, 15, 14, 13, 12. So 20 minus 8 gives me 12. So I now know that my bauble is worth 8, and I can put my bauble in over here. Now I will give you a few moments to work this out, and just hint, bed mass, make sure you do the correct order of operations. So which do you do first, plus or times? So I'll give you about 10 seconds, hoping that you can do that in your head. 15. Meanwhile, I'm just going to write it underneath so you can see it clearly. Right, so bed mass is the order of operations. I see that I have multiplication, which is the thing I'm going to do first. To work that out, which I would do in my head, but I'm going to jot down in light blue just above there. So first off, I have a 0, so I'm going to put my smiling or magic 0 over there, and now I'm going to do 2 times 8, which is 16. So that is 116, and 10 plus 160, sorry, 160. 10 plus 160 is equal to 170. So the final answer, where the question mark is, which proves that you are indeed a genius, is 170. Good job for those of you who got it. Don't stress too much if it's not something you got, but this is a great exercise to get your minds thinking and problem solving in a sort of silly, fun way. Okay, back to the presentation for the actual lesson. So last time we were working on perimeter, which is the length of the outside of a shape. Now we're working with area, which is the space on the inside of the shape. Lesson goals: understand first of all what area is. I hope you do already, but if not, we are going to just recap that. Then understand that area is a 2D shape. So when you've got an area, the area will always be making up a 2D shape. Finally, or not finally, middle, be able to count blocks to find the area of a shape. That's kind of grade 4 work, so it should just be a reminder. And then moving on to finding the shape, the area of an irregular shape, still by counting, also grade 4 work. And finally, this is where we start moving into grade 5 work. Be able to find the area of a square or a rectangle using the formulas. So when I say something is grade 4 work, it's not like then you forget how to do it. Just because something is grade 4 work, you should be able to do it in grade 5. So when we recap grade 4 work, it is a recap, but it's still things that you should be able to do. Maths is kind of like building a house. You got to build the foundation, then the walls, then and so on. And you can't leave anything out. And you can't just once you've built the roof, remove the walls, then the house will fall down. So it's one of those things where you've got to remember all the things that you've gone through, but it's one of the, like, the more you do it, the easier it gets. Okay, on to area. Area is the flat space inside a 2D shape. It's got 2 measurements, so 2D shapes have 2 measurements, and that's important when it comes to our units a little bit later in the lesson. Last year, you would have learned to find the area by counting blocks. That's what we're going to recap to start off with. This year, we learned to work with different square units. So a square millimeter, a square centimeter, a square meter, and a square kilometer. That little 2 up there is read the way that I just read it. So the first one is millimeters squared, centimeters squared, meters squared, and kilometers squared. But we also refer to square millimeters, square centimeters, square meters, and so on. Just what I mean by that, if I just jump across here, when I talk about a square millimeter, I'm talking about a shape that is 1 millimeter this way and 1 millimeter this way. So we've got this millimeter here and this millimeter there. We have 2 sets of millimeters. All right, so there's our dimension. So a square meter, obviously I'm not drawing these to scale, is 1 meter and 1 meter. This is a square millimeter. A square millimeter is when it's 1 millimeter this way and 1 millimeter this way. And then this area is 1 square millimeter, or 1 millimeter squared. 1 meter by 1 meter, 1 meter this way, 1 meter this way, is 1 meter squared. 1 square meter. Likewise, if I have a massive piece of land, which is 1 kilometer this way, and 1 kilometer this way, then this area here is 1 kilometer squared, or 1 square kilometer. So with areas, we always end up with this little squared, or power, up here on the right. Interestingly enough, this is not what the lesson is about, but just linking everything together. This E is for exponents, and these are exponents. We're not going to do any maths with the exponent thing. It's just a case of writing it down correctly. Okay. Quickly, I don't want to run out of time. Okay, yeah, looking at this. So this is again counting blocks. If we have a shape like the one on the left, you can count how many blocks there are inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of that is 12 blocks. Looking at the second one, I'm looking at my whole blocks first. 1, 2, 3, 4, 5, 6, and then these 2 halves make 7. These 2 halves make 8. Copied and pasted, silly me. All right, so that should be 8 blocks, and then this one we'd have to count all of them. I'll do my whole ones first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we do that. But we've got these strange ones like here, where they're not quite halves. And then what we'll do is we'll take this piece and together with that one, we'll say that's so if I took this one and turned it around, I could put it there. So then that would be 1. And we can count halves and get a rough idea of how many it is. And that's how we do the area of irregular shapes like that. There is another slide, but I'm jumping across to the whiteboard just to work out a few, and we'll come back to the last slide. Right, so having a look at the first one, we're going to start off with just some counting, just to figure it out. I hope you can make out the lines on your screen. They are quite faint, but they are there. Yeah, there we go. You can see them a bit better now. Right, so I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. 50 blocks. So area equals 50 D blocks. And please note that we write the word blocks because we don't have a square unit. Okay, that took a long time to count. And if you look at number 3, that's going to take even longer to count. So we're going to have to start thinking about how we can make a shortcut. So have a look at number 2. I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that is, no, we're going to write it properly, Mr. Travis. Area. You might have a teacher who's nice enough to let you say A instead of area. A is equal to 25 blocks. Looking at the next one. I'm going to have to count so many. Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Surely if this one's this column is 10 here, the next one's the same. That'll also be 10. That'll be 10, that'll be 10, and that'll be 10. So I can just go 10, 20, 30, 40, 50, and that covers all of these ones. Then I can go 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. And I can find that the area for 3 is equal to 75 blocks. Okay, looking at the next one, we have again got in number 4, we've got some whole ones and some half ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These two together make 11, then 12, 12 and a half. So A is equal to 12 and a half blocks. My next one has whole blocks and then partial blocks. Let's see how we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are all of my whole blocks. Let's look at the partial blocks. I think these two together make it 21, 22, 23, 24, 25. So my area for number 5 is 25 blocks. Okay, we are moving through these quite quickly because counting blocks is probably something that you're familiar with. And I want to get to just number 6, and then we're going to start looking at the formulas. This is, and please don't criticize my drawing, it's deliberately done like that to be awful. Yep. With these ones like this, where we've got partial blocks, near blocks, almost none of blocks, we're going to get an answer that's roughly equal to, and we use the roughly equal to sign, and your teacher will probably give you a little bit of margin on either side if you get if you're a little bit off. So I'd say that's almost whole, almost whole, almost whole. This one's not quite, but almost. So we're on to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's my whole ones. I would say that together those will go to 20, 21, 22, and then this plus those two make it 23. So I would say roughly 23 blocks. And your teacher would probably say you were right if you got anywhere between 22 and 24. So she would mark you right if you were anywhere between those two. Right. Now, this is where things get such a nerdy maths thing for me to say, but this is where I get excited about it, about maths, is we got these things. So remember, I didn't want to have to count all the blocks, and this is also a big shape. I really don't want to have to count all these blocks. So let me just go like this. Well, 1, 2, 3, 4, 5. This is 5 blocks tall. 5 tall. And that means that this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So my area is equal to 75 blocks. But I can also, let's count how many blocks long it was. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there were 15 rows of 5 blocks in each row. So what if I said 15 times by 5? 5 times 5 is 25, carry 2. 5 times 1 is 5, plus 2 is 7. Whoa! Just a second. Hold the phone. 75. 75. Wonder if that works for other ones as well. Let's have a look at this next one. I always tell my students that mathematicians are lazy. Maybe it's rather true to say they're efficient. They like to find workable shortcuts that get you the right answer. So this is a square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The square is 10 blocks high. Because it's a square, I also know that it's going to be 10 blocks wide. So all I'm going to do is say area is equal to the side times by the side. That's an S, not a 5. The area is equal to, and at this point what I'm going to do is put what the side is in, 10 times 10, and the area is equal to 100 blocks. You must write the word blocks, otherwise you've made a mistake. So in fact there I only needed to count one of the directions and I could get the answer. So this is pretty cool, knowing this little shortcut. Area for a square is equal to side times side. Let's look at number 9, because I have a feeling, number 9 is also a square. But this time things are going to be different, because instead of giving you or counting the blocks, what I'm going to do is I'm going to say that this is 10 centimeters. I realize it's not 10 centimeters, but let's pretend it's 10 centimeters. All right, because it's a square, both of them are 10 centimeters. Area is equal to side times, in fact, let me just write out so it doesn't look like a 5. Side times side. Area is equal to, and now where it says side, I'm going to write what the side is. 10 centimeters times 10 centimeters. Area is equal to 10 times 10 is 100. And because I've got 2 centimeters, see, I'm going to write centimeters squared. Dun, dun, dun. Number 10. It's a rectangle. We've looked at a rectangle before in question number 7. Let's have a look at this one in number 10. Well, I've got a long side and a short side, and we've realized that if we times them together, we can get our answer. So, area is equal to the length times the width. I've used 2 new words here. Perhaps you're familiar with them. When I had a square, all of the sides are the same length, so I can just call them side, and if I say side, you'll know which one I'm talking about. But a rectangle has long sides and short sides, and we call those long sides length and the short sides width. Okay, so now what I'm going to do is I'm going to take the actual numbers and I'm going to put them where the word is. So area is equal to, well, the long side was 10 millimeters. And the short side was 2 millimeters. Now I'm going to times the numbers. 10 times 2 is 20. There were 2 millimeters, or 2 sets of millimeters, so it's 20 millimeters squared. Hope this is starting to make sense. I've got a square. It's 6 meters long. I realize it's not 6 meters long. That's just what I've written there, but we'll work with that. So the area of a square is equal to side times side. Area is equal to 6 6 meters times 6 meters. Area is equal to 6 times 6 is 36. Times tables. There are 2 meters, so it's meters squared. And final one for today, as we're into the home stretch, I have a rectangle. The area is equal to the long side, length, times the short side, width. You might also have a teacher who calls it breadth. It just means the same thing. I'll write the word underneath, breadth. It's just another way of saying the same thing. Don't worry about it. So L times B or L times W, same idea. Area is equal to, the long side was 8 centimeters. The short side was 4 centimeters. 8 times 4, come on people, the 8 times table or the 4 times table. 32 centimeter times centimeter gives me centimeters squared. And that, very simply, is how we do areas of rectangles and squares using formulas. There are cool things that you can do, and perhaps if your teacher, I think they're cool. Perhaps if your teacher extends you, you might get asked to do something like this. So what if I had a shape that looked like, a shape that looked like this. And I needed to find out the area. Well, what I could do is to break that into 2 pieces. First, I work out the area of that one. Then I work out the area of that one. And then I add the 2 areas together and I can get my answer. And that'll give you the area of an irregular shape. You might also have a teacher who does something like this. Gives you a square with a piece missing out and says, what's the area of this part here? And what you're going to do is you'd work out the area of the whole thing, like that whole thing, and then you would minus, or you'd work out the area of this part, and you'd minus that. But perhaps this is only going to happen to you in grade 6. You don't need to know it, but what is coming up, because I have a moment to share this with you, is that there are formulas for working out the area of a triangle and other shapes as well, and circles. It's all very exciting. It's too exciting. I need to have a cup of coffee, a cup of tea just to relax. Right, so just a reminder quickly of those 2 formulas that we've learned. Sorry. Here's our formula for a square. The area of a square is equal to side times side. And the formula for a rectangle, the area of a rectangle is equal to length times width. These actually mean the same thing. Length times width. You could also do length times width, but it wouldn't really make sense because the length and width are the same. But you're doing the same thing. You're taking this and you're timesing it by this. It's just with a square, both of the this and the this are the same, and with a rectangle, they're different. Yeah, practice this by clicking on the link of the worksheet above and doing it, making sure you've got this. We will have a look at volume in our next lesson and perhaps touch on capacity and the difference between the two. I look forward to seeing you for that. If you'd like to email me, it's grade5@worksheetcloud.com. I'm Mr. T, grade 5s. Have an absolutely awesome day. Goodbye.